All right, hello, welcome everyone. Glad to see you here today at Java Day Istanbul. Hope you enjoy the conference so far. Nice talks. All right. The lunch was an hour ago. You should be more alive now. Coffees and stuff. All right. Okay. Okay. My name is Milen Dyankov. I'll be talking about giving application memories. Short info about me. I'm a developer advocate at AxonIQ. And AxonIQ is a company that provides software framework and an event store for Java developers, and that's the context of the memories. When I first created that presentation, which was quite some time ago, a lot of people were asking me, like, oh, memories, like, like RAM. And no, that's not what the presentation is about. It's not about the memory of your servers or machines or whatever. It's also not about Java virtual machine memory management, right? So you're not going to see the fancy XMA, X parameters and stuff like that. We'll be talking about memories as in remembering things. Right, and there's going to be a lot of movie references. Well, actually one, but we'll be talking a little bit about movies and making this association so you can better understand what am I talking about. Have you seen this movie, Memento? Anyone? All right, a couple of people. It's a very interesting movie directed by Christopher Nolan. And for those of you who haven't seen it, it's about a person who has lost the ability to form new memories. So everything they know up to a certain point they know, and then they are unable to form new memories after that. And what that person does is he actually writes stuff down on all kinds of things, on notes, on the walls. He tattoos stuff on his skin in order to be able to reference information back then. It's a criminal story. He tries to solve a murder, and eventually he does. But that, sorry? Yeah, no, I actually didn't. I just want you to think for a second about the idea of you not having memories or not being able to form memories, right? We don't think about those things on an everyday basis. We don't realize how important that is, right? But what if we can't form memories? And you may say, like, oh, come on, you're talking about a movie, someone came up with a story and, big deal about it. Well, that's actually a true story. That person, Henry Molaison, developed and that's real life, that's not a movie, he developed the same condition after brain surgery. He was unable to form new memories, right? So figure that out, like, what does it mean? How you operate in your daily life without being able to remember things? It sounds scary, right? But at the same, try, for example, a simple activity. And because I'm a presenter, I go to conferences, I travel a lot by plane. So that's an example I'm going to use. So try to book a seat in a plane, right? You don't actually need memories for this because the system is going to give you everything. You're going to have a map of the seats. You can pick a seat. You know the price. All the information that you need to book a flight, it will be made available for you. And you can book a flight. But what you cannot do is use your previous experiences of flying to make a better choice. Because after you've been using that system for a while, you now know that whether you prefer a window seat or an alley seat. That is not because the system tells you, that comes from your experience and from your memories. Whether you're okay with sitting next to the lavatories or not. Whether you're okay in sitting on the front of the plane or the back of the plane, all those things that you use to make a decision which seat to book, they come from your memories, from the fact that you've experienced something and how you use that information to make better decisions. And when we talk about systems, software systems, we are totally fine with them not having memories. Think about product catalog, for example. You basically have some sort of a storage, a database, a place where you know that those are the items in the catalog or shop or e-commerce or whatever that is, and where you store. Like we have a product That's the title, that's the description, that's the price, that's the stock quantity. That's what you know. And that's perfectly fine. And if I were to ask you how many of those products were in stock 3 weeks ago, you probably wouldn't be able to tell that, because that information is long gone. You've stored it at some point, and you consider it important to know what is it today. But what was yesterday, what was 1 year ago, what was 10 years ago, that's the things that we forgot about, right? We happily forget about those things, and we don't consider it a problem most of the time. It's interesting because actually every single system, if you think about it, well, maybe not every single, but like most of the systems, have memories. And just we don't use them very much. We call them logs. Like things happen, and we write somewhere, hey, this happened. And that goes to, you can actually send it to dev null. All right, it's forgotten unless a bug happens, and then you're forced to go in that log and dig into it and figure out what happened in the past 24 hours. That is a information that no one ever refers to. Now think about that. You go with a notepad or something, and you're required to write down everything that happens to you, right? And so you write, and you write, and you write, and then no one cares to read that, right? I mean, it's just such a waste of effort, if you think about it this way. But that's not always the case. There are systems that are actually making a very good use of their memories, or logs, and one of the biggest surprises in that field is actually databases. How many of you know that databases have transactional logs? And then they store every single change that occurs in a database in so-called transactional logs. So it's one thing that they have the state of the system, the state of the data as of now, which is the data they operate on when you request information or change information. But also every time you change information, there is a log to which the information about the change is appended. And that transactional log is actually being used, for example, when you replicate databases, or when you migrate things, databases can use that, and then you start new system, go through a transactional log, and update their state. Now that's unless you're a DBA, of course, that's probably not something you use on a daily basis, but it doesn't change the fact there are systems which are actually making good use of memories. So, if systems can have memories, right? And then do we need the state? If we have a system that records everything that has happened in the system, does it need to have the state as of now? What if we decide that instead of storing the state, we're always going to store the changes? So we don't store the state, we store the operations, the changes. And then when we want to know what the state is, we go through the log and we reach out to the point where we know what the current state is. Would that be interesting? That's actually a technique known as event sourcing. So, and there are quite a bunch of systems, and more moving towards that idea that instead of storing states, we store the events that led us to this state. To demonstrate, let's try this experiment. Try to answer the question: how much money do you have in your wallet, pocket, purse, whatever is the thing where you keep your money right now? Can you give me the exact number? You probably can't. But if you have a reference point that at some point in time you had X, and then you can think of like, oh, I had X, I spent so much on this, and someone gave me that. But you can fairly accurately calculate the amount of money you possess right now. What you're doing in your brain is event sourcing. You know the state at some point, and then you go through the events that had happened after that point, and you come to the conclusion of the state of today, right? And so it's doable, But then the people argue, like, well, but there's so many events. But when you do this exercise, between the point where you roughly knew how much money you have and today, you applied, what, 3, 5, 10 events at max. In that very same period, the number of events that has occurred in your life is much bigger, right? You probably had lunch, you probably grabbed a taxi, you probably walked, there are millions of events that had happened in the very same time frame. But those are not relevant to the question, so your brain immediately ignores them and only extracts the events that are relevant to the question, right? And so that's what event sourcing is about. It's not about going every time through every single event, but knowing which events are relevant for the context of the question and only going through those to rebuild your states. So applications which use event sourcing work similarly. They don't go through all the events that are stored in an event store. They just grab the events that are relevant to rebuilding their state. And for this to work, you need an event store that is capable of providing you with this capability, so you can tell that's what I'm interested in, and then only get the list or the stream of events that are relevant. So I talk a lot about theory, and that's all good and great, but you know what the difference between theory and practice is? Is that in theory they're the same, and in practice they're not. So let's try with a code. So we have a system, a very simple shopping cart for a bookstore. And I'm going to show you some code, but first I'm going to show you some diagrams. So that's the old school approach, how you build this. Basically, you have a shopping cart, you know how shopping carts work. You grab stuff, put it in there. Eventually, you remove something from there, then you check out. That's the whole complex process. So old style, you would probably have, so I have the client as a shell application, which you will see in a second, and then you would have this services, whatever micro parts you want to add to them. And you're going to have like create cart, add a book, remove a book, check out, and then one to check how many books. And then everything, all of this is traditionally stored in a database, so eventually you run some SQL queries there and get the data or update the data or whatever you need to do. Old-fashioned style. Now, we don't do applications these days this way anymore. Now we will separate it, and we'll have one for the adding and removing, and then we have a separate application for curing. And I'm sorry for the resolution. You would assume that hotels like this would have a better projectors, but that's what you get here. But eventually, but what this diagram shows you is like a separation, like two applications. One is only for adding and removing and stuff, and the other one is for curing, for like requesting information, so you can scale them independently. And you're probably going to snap some Kafka in between to exchange messages and things like that. So when you want to go event sourcing, essentially you get rid of all that. And you basically introduce an event store and say, whatever happens here, I'm going to publish an event. And publishing an event means I declare something has happened. And now, that is a powerful thing because events are immutable. If something has happened, it cannot unhappen. Something else may happen that changes it back. But the fact that something has happened it never changes. It did happen. I said the words. I can correct myself because I made a mistake, but then it's another thing happening. I'm saying other words. I cannot unspeak the words I spoke to you. And the same thing is with events. Event stores are append only. Things happen, you never change them, you never remove them, you never update them. They just keep happening. Right? And so here is a simple application, and I hope you will be able to read the code. And it consists of a few modules. What I have behind the scenes, which you don't see running, is an event store. It's called Axon Server. It's a product of the company that I work for. And that's the dashboard of it. And so as you can see right now, it's just the store. There's nothing connected to it. It gives you the ability to search for past events. So if I search now, it's going to find nothing because it's last hour. But if I search in general, you will see there have been events, some past events. I can actually count them. I have no idea how many are. It's like 50,000 events or so. And they're commands and they're queries. And commands and queries are the way to communicate between components. So when you want something to happen, you send the command. When you request information, you send the query, and someone responds to your query. And as you can see, right now, nothing happens here. So what I have in my application, which is here, I have a simple API. And that simple API, I defined a few things, like a block, object. The annotations are for Project Lombok. If you're not familiar with that, it essentially generates data objects. You can use Kotlin data classes for that, if you will, and whatnot. And we also have here a definition of commands. Let me see, yeah. Classes that represent commands and classes that represent events. So this represents a shopping cart command. And so you can see we have a add book command, checkout command, create shopping cart command, and remove book command. Right? So it's just plain Java classes. There's nothing really, nothing special about them. And then we have events. Now, command is call for action. You request something to happen. Event is a notification that something has happened. So we have book removed, checkout, shopping cart created, book added, you know, those things. And so now we also have the client application, which is going to connect to through the Axon server to other applications and operate with that. What that application does is it has a couple of functions. One is it can simulate a client shopping. So quite a lot of the code, the important parts are here. So we create a shopping cart at some point, and then we use this thing called command gateway to send that command. In this case, synchronously. So we send and wait. We can also do it asynchronously if we wanted to. And so then we send this command and wait for confirmation, and then we iterate to a number of books that we want to buy, and then for each book we send another command, which is a add book command. So we're adding a book to the shopping cart, and then eventually we are sending the checkout command. There is also an algorithm which randomly removes a book from the shopping cart. You'll see why is that. And so what I'm going to do is I'm going to start that application right now. That's the shell, the right one. Okay. And what you will see here is that my application will immediately connect to the Axon server. So I can click on that application and I can see, oh, that application has some sort of ID, and basically does nothing in here. It does not register any commands or queries or anything, right? So if I then go and run that, so this is my application here running, and I can say buy books, and this is what runs this the shopping simulation part, and you get an exception. Now you can think of that Axon server thing as a messaging platform. The difference between the messaging platform and what we have is that if you send a command and there's no one to handle the command, you're going to actually get an exception. You're going to get an error telling, hey, no one knows how to handle this thing, right? So now you can react to that and can say, okay, I'll do something else, or I'll record a log message or whatnot. So for this to work, we need a code that can actually understand that. And that code is in a different application in here, and it's an aggregate using DDD terminology. It's called shopping cart. So the shopping cart, as you can see, has method that is annotated with command handler. And command handler receives a command, in this case, create shopping cart command, and then it does some validation whether or not that command can be handled, and then publishes an event. That's the code right here. When the decision is made that we can process, we can just say, that happened. A shopping cart was created. The same with command handler for adding book and removing book. That code also receives its own events, right? So you can see here that it receives book added event, book removed event, and whatnot, and then it updates its state, right? So I can, on a shopping cart created event, it associates a shopping cart ID and a person ID and whatnot. So if I run that code now, here, I'm sorry, we're getting lost a little. Shopping cart service app, let's run that. So you will see another application popping up here, right? Also connected to our event store and our messaging platform. And if I click on that, now you can see that actually there are commands that this application can handle. Those are these 4 commands: create shopping cart, add book, remove book, and checkout. It can also handle a query, which is tell me how many books I've purchased. It has a, that's how the tracking things goes on. I'm not going to get into the details for that because I don't have the time now. But you can see quite a lot of information about that application here. So now, going back to my code here, which the first application, which I never stopped. I'm just going to make it full screen so you can better see it. If I do buy books, you can see it goes through the process. It adds a book to the shopping cart, it removes a book from the shopping cart, and then adds 3 more books to the shopping cart, and then does a checkout. Now, what you can see on the other side is how the thing is handled when the command is received. So this is the first time the command is received. We create a new shopping cart object, right? And then we handle a create shopping cart command, and then we publish the shopping cart created event, right? And then we handle the same event on our side. Now, and that's it. We're done. The object is destroyed, right? So then a new command comes, add book, and then we create a new shopping cart, and then we go to the event store and say, hey, give me the history for that ID, and then we get, oh, there was a shopping cart created event, so we get the information from there, update our state, and handle the next event. And that process repeats for every single command. Now here is the remove book command, here is the next book added, here is the next book added, and you see this stack here grows because every time we create an object, we go through the memory, to the history, and build our state based on what has happened before, right? Up until the moment you reach the final checkout command, in which case all that here is building from previous state, and you're only handling the last event. Right? And so if you go now to here, to search, and you just search in the last hour, you will see all the events are stored in there. So we had an event, say shopping cart created, product book added, book removed, book added, whatnot. So everything that has happened in the system is stored in the event store. For the life cycle of the application, you can also see the number of queries and the number of commands that are being executed. So we still have no queries here. I can actually run a query to just show you, for example, say sold copies of what? There's going to be some Harry Potter and something in here, always is. So like 295 copies of Harry Potter were created. So that's very simple application that basically, and now you see that one query was executed. So that's a very simple application that consists of actually 2 microservices, if you will. And then you can implement this in multiple different ways. And if I tell you should implement it this way, you'll be like, yeah, but I can just do it in whatever am I doing normally, right? So then the question is, That thing, you develop it in any way you wish, whatever technology works for you, you're in production. 3 years down the road, 2 years down the road, a product manager comes to you and says, listen, we came with this great idea. We're going to give 10% discount to every person who in the past has added a book to the shopping cart but didn't purchase it. So there was an interest, apparently. They added it to the shopping cart, but they decided not to purchase it. So we want to kind of encourage them, so we're going to give them 10% discount. Can you implement that with your approach? Your answer would be, you should have told me this 2 years ago, man. I have no idea what they have added and removed from their shopping cart, because all I have is state. Ask me what is now, I can tell you. But what they've been doing all this time, it's gone. We never ever recorded it, right? If you were given this condition up front, you would have come up with an idea to store that information somewhere, because you would know that that information is useful. But because you're only given that information now, you need to operate on data that does not exist, so you can't do it, unless you implemented it with event sourcing. If you implemented it with event sourcing, you say, of course, no problem. And you go and you build another module in here, which we're going to call an upsell service. And the upsell service is essentially going to build a projection. And then what we're going to say is, I'm an event handler, so I handle all the events that of type shopping cart created, and also book removed and whatnot. So in this simple piece of code, I have actually 2 maps. I'm doing this in memory. Obviously, for production, you'll do it in a much smarter way, which is mapping a shopping cart to a person, and then mapping and then tracking which books given person considered buying but didn't buy. Right? And I do that because going through the history for every single event that has occurred in the past, my method will be called, and then I can add it to the respective map. And then I also provide a query handler, which is books considered before query. And so if someone asks that, I'm just going to go through my maps and return them an information. And so in my client code, I have something that I've added earlier, but normally you would add it later. Like in the purchasing process, you would send a query and say, hey, give me the books that this person considered before. And that someone's going to respond to that query of yours and give you that information. And so if we now go and run this upselling service application, what you will see is that there's going to be another application attached to our data store, to our event store and our message router. And that's pretty much it. If you click on that, you will see that it provides a query, books considered before. That's all you know about it. Now, if I go back to my code in here, and let's clear that again, and I run buy books again, and if I'm lucky, I'm not. Emma apparently did not do that in the past, so let's try again. Charlotte logs in, and we know that Charlotte was considering buying Charlie and the Chocolate, Cosmos, Catching Fire, and Charlotte's Web. So for those books, she gets 10% discount, right? You don't believe me? Let's try that again. Everett didn't do that. Let's clear it again. Buy books. Here, Scalar gets discounts on different books. So I just implemented a functionality that operates on historical data, that uses memories, because my application was built in a way that collects memories. It's a requirement that came up late, that's based on information that I didn't know earlier, and I can still do it because of the architectural style of the application that I choose. If you don't need it anymore at any time, all you can do is just stop that service. And then if you stop that service, then you can again run this as many times as you want. You will get no discounts at all, right? Because that service does not run anymore. So that is the application that we had originally. And someone came up with new business functionality, new business requirement, and we were able to do it by just introducing yet another service, which is making use of the event store. Now, the typical questions that pop up at this moment, like, okay, but you're sharing this with like 50K of events. I actually initially did this demo with like 500 million or something, just to demonstrate the fact that it doesn't really matter. But obviously, if you have something that only appends things, it will ever grow. So sooner or later, you'll reach the point where reading all the stuff from the past is not going to be performant, right? So for this, you need a bunch of techniques. And so, because we're in the movie reference, that's the final slides related to our slide. So you need an efficient event store, first of all. And in this case, the role of the efficient event store and also the messaging platform is played by Axon Server. And then you need a convenient way to talk to this. And that's those message buses that you saw, command gateway, event gateway, and query gateway. Those are provided by Axon Framework. Your data is still POJOs. We don't enforce any means of how you should structure your data, because you're the domain expert. You know how data should be, what makes sense for your data. But then you also need to have ability to optimize things. So what you can do, for example, you can do snapshots. So you can say, you can configure the whole system to make a regular snapshots, for example, every so many events, or every day of the week, or every day, or every year, or whatever makes sense. And then what you have is you have a snapshot of a object, of a aggregate at some point, and when you restore, when you try to load, you don't read all the million events in the past, you get the latest snapshot and the events after that. And in that case, it typically goes down to a handful of events, which goes in milliseconds, right? Other things you may want to do is you may want to intercept messages, because things will change. Now, we defined 3 classes about like what is the add book command and delete book command, and with time, you may want to represent those commands in different ways. Right? You may want to add a field to a command or an event, right? Well, command is not a problem, because command is like it's received, it's processed, and it's gone. But for events that you're storing, that may become a problem. All of a sudden, you have an event store which stores a bunch of events in one form, and from some point on, stores them in another form. So in this case, you need things that, like upcasters. You need to intercept the communication and basically say, from now on, if you receive this event, convert it to the new version, right? And you can do things like that. The other thing that you want to do in such environment is to have a good exception handling. So as you saw with commands, it's not like a traditional pops-ups or streams or topics where you just send something and hope someone's going to receive it and do something about it. In this approach here, you would very much want to know, if you issue a command, if there is someone who can handle that command or not, and if not, what you want to do about it, right? Maybe you send another command, maybe you do a compensating action. That's part of the business logic. You may want to do a complex stuff. The example that I showed here so far was very simple. But what if you also have I don't know, send notification and stuff? Then different services and different aggregates, speaking in DDD terms, get involved, and you may want to orchestrate how those things behave. Like when I send a message, that sends another message and whatnot. So for this, you would probably want to do things like saga pattern and whatnot. So we have also those. You may need the deadline feature, right? Because you say, I'm sending a command, right? And or I'm waiting for something to happen, but I'm going to wait for how long, right? You know, maybe milliseconds, maybe days, maybe months, right? Or for example, you do a accounting system, you issue an invoice, right? And you have a payment deadline, right? If no one paid that invoice, no event is received that says the invoice is paid in some period of time, you may want to act on that, right? And so on and so forth. There's tons of features that you actually would need in order to make this production system efficient. And we hopefully provide most of them, if not all of them. What I was showing you is a very, very basic example, just to understand the idea of storing history and making use of it. But there's a whole lot more about that. Obviously, a bunch of integration tools around that. We have probably the most popular is Kotlin extension. For some reason, people get crazy about Kotlin these days. There's also a Kafka connector. Theoretically, you could use a MongoDB or any JDBC database as an event store. So if you don't really want to use Axon Server, you can just use the framework and then store your events and wherever you want. The problem with that is that the traditional stores are not optimized for a append-only approach. They need to be able to update, delete, and insert stuff. And so they cannot get rid of those things. So they optimize for all. And so with time, the performance with those will certainly go down, because the more events you store, the harder it will be to use them. With Axon Server, you pretty much have a linear performance regardless of the number of events. And actually, that was confirmed by a customer of ours quite recently. They were very stubborn for a while that they're going to use Postgres, and they discovered on their own that that wasn't a good idea for events, right? I'm not saying that Postgres is not a good database. Yeah, it's great and it does great things. But for this use case, it's just not comparable. And I'm not going to bother you with more things. That's pretty much all I had for you. I had a bunch of links on the far right. That's our developer portal. If you want to read more what we write. We have an online course system called Economy Axonic.io. And Axonic Academy has a couple of free courses about DDD, event sourcing, and CQRS. If those are new to you, you can learn them there, and then there are more courses about the actual products. And we have a Discuss forum where we can welcome all the community members, and it's not about questions like it doesn't work, help me out, but also about design questions, about architecture, about how do we put things together, does it make sense this way or that way, and it's a very interesting forum because you get to talk to people who are actually followed that road before you, and they can give you valuable advice of like, hey, we did this and it didn't work, right? And then you're like, but why, and whatnot. So if any of this that I said today is of any interest to you, look for yourself, try to see whether it fits in the projects that you do or not. Maybe it does, maybe it doesn't. I'm not claiming that you should change every single application in the world to use this approach, but my guess is, and it was the case with me before I joined the company, is the more you think about it, the more use cases you find, the more often you reach the case where you tell yourself, if I had that in that application, right? So decide for yourself. All I wanted to do today is show you what's on the table, what you can use outside of the very popular technologies that we deal with every day. Don't hesitate to reach out to me or Axonic. That's my Twitter handle somewhere there, and also Axonic ones, or any social, whatever is your favorite social media. We're pretty responsive. Thank you again for joining me for this talk today. And I think we still have a couple of minutes for questions, right?
Yeah, we have 5 minutes. And also after that, we have coffee break. So
yeah, I'm not going to steal your coffee break from there.
Yeah, if you have questions, we have plenty of time. So
yeah, all right.
Raise your hand. I can bring you microphone.
Here in the first row.
Oh, okay.
Thank you. In a scenario that we want to restore our database with an earlier snapshot. So the data, how does that framework sync with the database snapshot? Because the events are stored in another server, and database is in another state.
Okay, so if you want to sync with a database, and that's one thing that I didn't show you actually, because I was afraid I'm not going to have enough time. So let me quickly go back to the code in here. So I show you here that for the service application, the shopping service app, it handles a query. All right, I didn't show you how that's implemented. So let's quickly look into that. So that is in the, where is it here? Shopping cart. So what you see in here, book purchase projection. So there is this notion of projections in CQRS and domain-driven design, they kind of overlap a little bit. So what you see here is a component that is an event handler. So it handles the checkout event. Right? So every time there is a checkout event, it's going to go to this component. And what this component does is it gets that event, it goes and checks what the books are inside that event and whatnot, and then it stores in this sales map, I believe it is. Yeah, hash map. So that's like an in-memory database, if you will. So obviously in production you wouldn't do it that way. Obviously in production you would have your database here, or whatever is your favorite way of storing data. And then that same component is also a query handler. So whenever you receive a book purchased query, it goes and checks that sales map and gives you the number of books purchased, right? So it has two important things here. First of all, it doesn't really care about the shopping cart itself. It just operates on all shopping carts, right, and it makes the map. Second of all, for this one, it stores it in a map, but you could do it in a database or whatnot. But what's even more important is you can have multiple of those. Right? It is not limited to one event handler. You can have multiple event handler. And so, for example, if your system is something that needs to provide a web UI and also a DB analytics, right? What you may want to do is you may have one event handler that receives the events and directly generate JSON objects. Right, and you store those somewhere. And so when your UI says, give me the view for this purchase, you don't have to go to the database and construct it and whatnot. You just grab the JSON and here it goes, right? But on the database analytics, data mining, whatever else systems, then you can use a database to run your analytics on top of that. And you can do multiple databases, or you can, in case of users, you can say, I'm just going to store my user directly in my LDAP server, right? So it doesn't change at all about the fact that there is an event, that something has happened, right? So something has occurred, you've informed the world that something has occurred, and then it's the respective component that needs to know what's to do with this. Like, how do you update your database? How do you update your LDAP server? How do you persist your view models? There are tons of, or you can generate PDF files if you want and store them on a file system, right? Every time an event occurs, right? So this allows you to also shift, and if you do this asynchronously, it doesn't impact your regular operations, right? And but speeds up your read operations because they don't have to go through the process of generating the proper data for whoever is requesting it.
So the events are stored in like Kafka or something like?
They're stored in the event store. So the Axon server is the event store. So if you use Axon server, obviously.
So if we brought the synchronization between the events and the database, because if we revert or restore some data that we took snapshot earlier. So the events are coming from the future because data is.
So you mean you have a legacy database and you want to convert it to event store solution, or because I'm not sure I understand the question.
Okay. The events are coming and not processed at that time.
All right.
We can think, and the database is restored from a snapshot that because we have a problem.
So first of all, for operational purposes, let's stick to the term of event store, because if there is a state changing operation, we need an event store that from which you can. An event store is an abstract term. You can have an event store that's backed by a database. That's an implementation detail. What you need is a conceptual event store that you can say, give me the history, give me the stream of past events, right? So if you have that, no matter how it is implemented, right, you have no problem. Now, if you have event store and a part of that want to have a database and keep those in sync, then how you do it depends entirely on you.
Okay, so framework doesn't provide a solution for that.
It provides you the tools for you to listen and react to events, right? If you use Axon Server, it provides you with the event store as well. Right, it's a router and a server and a data store and an event store in one, right? But if you choose to use a different event store for whatever reason, you can do so. If you choose to use that event store, but then on every event sync with other database, then you can provide your own event handler. And then event handler can do whatever it needs to do, right? There's no restrictions on that at all, right?
Okay, thank you.
You're welcome. All right, I think we're out of time for questions. But
any question?
Again, I'll be around, so if you have more, find me. I'm happy to talk to you all.
Yeah.
Thank you again.
Thank you so much. Thank you. That was a great presentation.